Okay, this is going to be a video going through some completing the square problems as related to integrating when it's an arctangent situation. As a reminder, we want to use an integral with an arctangent when the numerator actually has a degree of 0 or it's a constant. You'll notice that the denominator here, a squared minus u squared, is going to be some kind of power. But the important thing is that the numerator doesn't have any x's in it. If there are, I might want to look at long division if the power is higher, or I want to look at u substitution if the power is lower. But if we have a problem like number 23 from the textbook, we can see we've got x squared in the denominator and the numerator is just dx. So I'm going to rearrange this problem to become x squared, oh, that is not in the right spot. X squared plus 4x. We're going to kick out the constant. Oops, already had that. And now I'm going to add what I need. I need this to be a perfect square, so I'm going to take b divided by 2 and square it. So I'm going to put a 4 here. Now, if I put a 4 here, I need to subtract a 4 here. So now I have the integral from -2 to 2. I can factor what adds to 4 and multiplies to 4. And then this becomes just a 9, which is very convenient because I can easily identify that here is my u, and nicely du is 1. I don't need to worry about doing any u substitution here. And this is a 9, so I know a is 3. So I can now integrate this, and it is 1/3 arctangent of u over a. And I'm evaluating this from -2 to 2. I'm going to pull out the 1/3 as I do the definite integral, just because it's a little easier. So I have arctan of 4/3 minus arctan of 0. And arctangent of 0, what angle has a tangent of 0? That's just 0. So my final answer here would be 1/3 arctan of 4/3. Okay. Now let's go to the problem from tonight's homework, number 5, which is an indefinite integral. The first thing I notice is I've got a 2 here, a -2. I'm going to pull it out. So I'm going to go -2 integral 1/, and I'm going to start to rearrange this denominator. So when I separate the constant from the variable terms, I notice my variable terms contain a 3. So I'm going to factor that out also. So I've got x squared plus 10x. I'm going to leave some space here. And then I'm going to put the plus 81 over here, dx. Now, I need to fill in what will complete the square. So 10 divided by 2 squared is going to give me 25. So I'm adding 25 in the parentheses. I have to neutralize the fact that I'm putting 25 in the parentheses. What I'm really putting in the denominator here is a 75 because it's 3 times 25. So I need to subtract 75. I'm going to rewrite my integral as -2, 1/3, and then I'm going to have x plus 5 squared. And then -75 plus 81 is 3, or is 6. I don't know what my problem is. Trying to go too fast. Before I identify a and u, let's just go back and look at our formula again. You'll notice that like it's just supposed to be u squared and a squared. And here I've got 3 and this is u, and this could be the square root of 6, but I need to factor out the 3. So if I factor out the 3, I need to take it from the 6 also. So now I have -2, and I'm going to take out, this is going to come out like a 1/3 here. So it's going to become -2/3 times the integral of x plus 5 squared plus 2. Here is my u, and a is going to be √2. So I've got negative 2/3 times 1 over A arctangent of U over A plus C.